Hello everyone, my name is Ansh Ashok Shriwas. I am studying BTech in Electronics and Telecommunications from MIT Academy of Engineering. I am doing this presentation as a graded activity of our Digital Signals and Processing subject. Our guide is Mrs. Nutan Bansode. Today we will be learning how to remove high frequency noise from an ECG signal. But firstly, let's see what is an ECG signal. ECG electrocardiogram. It is a graph of voltage versus time of the electrical activity of the heart using electrodes placed on the skin. And electrocardiography is the process of producing ECG. It provides a wealth of information and remains an essential part of the assessment of cardiac patients. However, noise distortions associated with the signal could lead to wrong interpretation and diagnosis. Working principle of electrocardiography. It works on the principle that a contracting muscles generates a small electric current that can be detected and measured through electrodes suitably placed on the body. For a resting electrocardiogram, a person is made to lie in the resting position and electrodes are placed on arms, legs and at 6 places on the chest over the area of the heart. The electrodes picks up the current and transmit them to an amplifier inside the electrocardiograph. In an electrocardiograph, a sensitive layer traces the changes in current and display the current on an oscilloscope screen. Application of ECG. It indicates the rate and rhythm or a pattern of contraction of heart. It gives a clue about the condition of heart muscle and is used to diagnose heart disorders. It helps the doctors to determine whether the heart is normal, enlarged, or if its certain regions are damaged. It can also reveal irregularities in heart's rhythm, known as arrhythmia. It is used by doctors to diagnose heart damage in conditions like high blood pressure, rheumatic fever, and birth defects. And ECG also helps to determine the location and amount of injury caused by a heart attack and later helps to assess the extent of recovery. We will use FIR filter for removing this noise from ECG. FIR, finite impulse response. As the name suggests, these filters are digital filters which have finite impulse response. FIR filters operate only on current and past input values and are the simplest filters to design. FIR filters are also known as non-recursive filters. FIR filters provide a linear phase response. They are always stable because they are implemented using an all-zero transfer function. FIR filters are used for applications that require linear phase responses like high-quality audio systems. Flow of project. Firstly, we have downloaded a sample of ECG signals from physionet.org. Then we have loaded it in our MATLAB project. And then we have removed base and gain using some functions. And we have calculated the time from sampling frequency. Then we have plotted the original ECG signal and then we have designed FIR filter. Using that filter, we have filtered the data into variables and finally we have got the result of noise removed ECG signal. This is our code. Firstly, let's see this statement, that is y is equals to y minus 1024 by 200. Here 1024 is base and 200 is gain. This is used to remove base and gain. We have got the values of base and gain from the .info files of ECG signals which we have downloaded from Physionet. So this is the file. Here you can see the sampling frequency is 250 Hz. This is for another record. Sampling frequency is 250 Hz and gain is 400 and base is 0. So, the statement will be y is equals to val minus 0 divided by 400, and sampling frequency will be 250. Here we have derived the same. Let's see this statement, that is v is equals to FIR 100, 0.07, 0.13 stop. This statement helps in designing FIR filter. So here it is read as A is equals to FIR1 and here n is the number of taps. F1, F2. F1 is lower frequency, F2 is higher frequency. Stop represents stop band. For low pass filter, we will use low. For high pass filter, we will use low. For high in commas. Yeah. Here, F1 and F2 are normalized to the Nyquist frequency. We know Nyquist frequency is equals to sampling frequency by 2. For example, let's take sampling frequency is equal to 1 kilohertz, that is 1000 hertz. So Nyquist frequency will be 1000 by 2, that is 500 hertz, and normalized frequency will be 50 by 500, that is 0.1. Here you can see 0.07. We considered it as lower stop band and 0.13 as higher stop band, as 0.1 is normalized frequency. Now let's see the demonstration. This is the name of the ECG signal we have used. In that 1024 is base and 200 is gain, while sampling frequency is 1000. Let's run this. You can see this is the original signal and this is the filtered ECG signal. The filtered ECG signal is crisp, while the ECG signal which we have downloaded was a little disturbed. Conclusion. So ECG provides a wealth of information and remains an essential part of the assessment of cardiac patients. But noise distortions associated with the signal could lead to wrong interpretation and diagnosis. So the removal of noise is very important. Hence, the noise corrupted ECG signal is handled through FIR filter and the desired smooth signal is obtained. These are the references we have used. Thank you. If you have any questions, you can comment down. Thank you very much.